Okay, this video will demonstrate a simplistic devoid bulb of any metal electrodes. It possesses a mixture of mercury vapor as well as caustic potash vapor, so that the objective is to obtain a similar effect to what Nikola Tesla would have most likely experienced, given that he used a Sprengel Mercury drop pump. Now, this bulb measures about 3 inches in diameter, and it is placed in between two inward-facing coils operated in cosmic induction mode generator setup. And these coils are conical coils, so that to experimentally see how these coils behave as opposed to the traditional elongated coil. Now, the two metallic spheres are the two experimental capacitive loading ends, which will inadvertently distribute the dielectric lines of force evenly around the bulb and around the material around the bulb. So now I will increase the power and go to the transmitter supplying these coils. Okay, we have now keyed up the transmitter. It is running right now at only 4 watts. We could see that there is a faint glow in the bulb. That's the residual mercury vapor, as well as any remaining water molecules and oxygen molecules trapped within the bulb. I have tuned it up for this purpose just to see where the setup is going to land in terms of frequency, and right now we're operating at around 5.436 megacycles. And again, I want to say that we're only delivering 4 watts into the system, in which these set of coils exhibit a magnification factor of 800, in that the 4 watts going into the system are being effectively magnified by 800 times. Now I will turn the lights off, and we will then slowly begin to increase the power to see the effects observed. Okay, the lights have been turned off, and I must say that the color being depicted by the camera right now is more of a turquoise color, when in fact the actual color is more of a whitish, very light purple, quintessential of mercury vapor. Now I will start to slowly increase the power, mining the SWR of the transmitter and tuner, and also the frequency is most likely going to be dragged down as the plasma inside the bulb eventually warms up. So now it is at 4 watts. Now I will start to slowly increase the power. Okay, 22 watts. I will adjust the SWR. I am lowering the frequency. And in the background, I am adjusting the antenna inductor of the tuning unit so that the SWR is effectively minimized. Okay, it became a little brighter. Now we will step up the power to 40 watts right now. Let me increase and adjust the frequency and inductor. Okay, now we're at 5.41 megacycles. And I have adjusted the inductor. Let's bring it up in power. 66 watts, lowering the frequency. Once more. And we're at 5.39 megacycles. I will increase the power once more. 82 watts. Lower the frequency. Okay, now we're at 5.38 megacycles. Adjust the inductor. And now we are at 100 watts. And our frequency has to be lowered again to 5.3 megacycles. Okay, now the formation is starting to take place. A separation is occurring, which is of a pinkish hue. It has transformed color, and now in the space of cancellation, there will emit a mercury line, so to speak. So let's give it time. We see that there's an effect occurring near the base of the bulb. And eventually this mercury will become excited to expand towards the top end of the globe. And now the mercury line has formed. See, by adjusting the frequency effectively, we are now at 5.37 megacycles. And the line will start to vibrate now as it becomes heavily excited. You can see that there are multiple lines, about 4 of them. And if I continue to adjust the system, so that to maximize efficiency, you find that around there is the most optimum spot. And we have 3 sets of lines appearing. Now, of course, this seems to be dependent upon the placement of the bulb between the null zone. So now I will shut the power off and relocate the bulb slightly more towards the left so that it is in line with the cancellation zone, because right now it seems to be slightly off balance. Okay, we reposition the bulb so that it is slightly leftwards, but also slightly by about a centimeter taken out towards the camera, out of the direction of the coil. So right now, for tuning purposes, we're set at 8 watts. The frequency is higher now because the actual ions inside the bulb haven't reached their excitation level. We are sitting at around 5.49 megacycles, roughly 5.5. And I will now increase the power and we will observe the frequency decrement. Okay, we're at 26 watts. Let's retune the system. We are decreasing the frequency. Right now we're at around 5.39. We are adjusting the tuning condensers. And we have reached optimum capacity right there. So now we will increase the power once again. We are at 38 watts. And we will adjust the frequency again, 5.38 megacycles. Now we will increase the power, 56 watts. Decrease our frequency. Around there. 5.37. We see that the lines are already appearing because the bulb has been warmed up. We adjust our inductor from low SWR. Increase the power again, 70 watts. And let's see, the bulb went dark for a second. Okay, there we go. 5.36 megacycles. Increase our power from 70 to 85. Lower our frequency to about 5.359. Increase to full power, 100 watts. Just our frequency. And we are sitting at 5.356 megacycles. And our SWR is 1:1 now. So we are sitting at maximum power efficiency. And we can see that there are fewer lines now, but this will likely change as the bulb continues to warm up even more. And on this end, it seems as though that the camera is measuring the brightness. Now I will pause the video and bring the bulb closer inwards, or that is, move the coils inwards more so that to hasten the effect. But we can see already that the lines are starting to vibrate, so actually let's let that happen. we could also hear that there is a vibratory action, a high-pitched audio oscillation emanating from the bulb, which indicates that the oscillating, vibrating lines occurring in the bulb are also simultaneously vibrating the air molecules around it at a possible frequency corresponding to the operation of the bulb or the setup as a whole. So by having the coils move inward further, then we should amplify this effect further. So I will pause the video now. Okay, we moved the coils inward more so than before. And right now, for tuning purposes, once again, we have the power low. We are sitting at 6 watts, and the formation seems to be slightly different, that this cloud of charged ions is residing towards the top of the bulb. So now I will increase the power. And by the way, we are sitting right now at a frequency of 5.447 megacycles. Higher, and will then become lower as the plasma becomes more excited. Okay, we will increase the power. Okay, that's 23 watts, just our frequency. Okay. It's around 5.2 megacycles. Lower than before because the bulb and the coils are closer together, therefore the capacitive burdening is greater, hence the frequency is lower. So I will now tune for optimum condition, and I will increase the power from 23 watts to now, let's see, that's 40 watts. We will readjust the frequency. Okay, that's 5.17 megacycles. Just our tuning inductor. Okay. Increase our power to now 55 watts. Change our frequency. We are at 5.16 megacycles. Okay, increase our power now to 76 watts. Our frequency is now 5.14 megacycles. Let's continue to increase. We're at 89 watts. Lower the frequency. Just our tuning inductor, low SWR right there, 1:1. And we will now go for 100 watts, and we can see that the illumination of the bulb's color is now white. That means that it's even more excited now, and we will see a very interesting transformation. So right now we're at 5.142 megacycles, and pay close attention as to how these lines will start to appear out of the dark space or the null zone. We are still maintaining an SWR of 1:1, which is quite decent. And now the lines are becoming more profound. Notice how the color has changed from almost a bright white color to now of a pinkish hue, which is a mix of the mercury vapor, the caustic potash vapor, as well as the minute amount of water molecules and oxygen, along with silica, which emanates from the interior wall of glass, granted that this is borosilicate glass. Okay, our SWR is maintaining itself. So now we will let the formations proceed. And we can see what is rather interesting is how the lines are now to the side, which indicates that the bulb has not been placed directly in the null zone, even though it is probably slightly off of about 0.1 or 0.2 centimeters from being directly in the null zone. So let's see, I'll probably ever so slightly move the bulb so that to place it in the null zone. I am now holding the base and I will move it. Okay, now just near the null zone, which is around right there. And we could see that by just slightly adjusting its position that the lines will become rather chaotic. And we seem to have more lines appearing now, more pairs forming. And I must say that from a great distance, with respect to the bulb, that this high frequency pitch of sound emanating off of it is audible. And let's keep the bulb right there. Let's see what happens. Okay, it seems to be slightly stationary near the base, and from the viewpoint of the camera, the lines are quite pronounced, except when you look at the bulb from a horizontal or a perpendicular point of view, then it's simply a turquoise blur, which is another interesting feature of this bulb. Okay, now it seems to be behaving slightly more chaotic, so let's keep the setup there. Our frequency hasn't changed, so that the plasma seems to have reached a equilibrium, so to speak, with respect to frequency. We are exactly tuned to 5.13 megacycles and pumping 100 watts of continuous wave power into the coils. Okay, to make things interesting, I will move the bulb a little bit to see if any noticeable effect occurs. Okay, that's moving it to the left. This is moving it to the right. Let's keep it right there. Okay, that really changed our frequency, so we now have to decrease it down to about 5.113 megacycles, but that's alright. Okay, our SWR is now 1:1. And it seems as though that these pairs of lines are a little bit more stationary, but notice how they do conform to the so-called counterspatial field zone collapse, or the dark space in the middle. Now, once again, I will move the bulb and see what happens. And it went dark. Okay, well, threw it off tune. Let's retune it again. Okay, once again, has that slight movement of about half a centimeter to the right through the whole system off tune. Now we placed it back to the center, but we did move the coils a little bit more inwards. Okay, we're at 6 watt, 5.52 megacycles. Let's increase the power. Okay, 26 watts. Let's lower the frequency. Okay, now we're at around 5.19 megacycles. Okay, let's increase the power. Okay, that's 44 watts. Lower the frequency, 5.165 megacycles. Increase your power, 55 watts. Change our frequency again, just our inductor. Okay. And just our antenna condenser, 55 watts. Now we're at 70 watts. Okay, let's increase the power. 81 watts. 5.141 megacycles now. And we're at full 100 watts. And retuning our frequency. We're now at 5.136 megacycles. And we see the effect starting to take place once more. SWR still very low. And the bulb went off, okay. Let's retune the setup. Let's go to a higher frequency. Okay, our bulb has ignited. Okay, let's increase our power. We were at 12 watts. Now 27 watts. Okay, now we're at 42 watts. Our frequency now 5.179 megacycles, increasing power again, 58 watts. Frequency is still going lower. increased to 71 watts. And we're at around 5.15 megacycles. Let's tune our antenna matching unit. Okay, oh, it went dark. Okay, let's keep tuning. Okay, 5.148 megacycles, 71 watts. Now we're at full power, 100 watts. Reduce our frequency. 5.14 megacycles. Just our tuning inductor. Okay, and now we are at maximum efficiency. 5.141 megacycles, 100 watts, SWR 1:1. And there we go, the lines will start to oscillate and grow in number. Now we could determine that because these lines are fairly vertical with respect to the 90-degree horizontal line portrayed by the coils, that it is indeed in the zone of cancellation. We could also see that the jostling associated with a out-of-distance cancellation style, that this bulb is now reached a point of equilibrium. And now I will take the camera around the setup. So that to show just how these lines appear from different points of view. So now I am moving towards the left coil, perpendicular to where the camera was initially spaced. And we could see that these lines will then become a blur. Moving now towards the center where the camera initially was. Now the lines appear as definite lines. Now we move towards the right coil. And likewise, it is also a blur, which makes this effect quite interesting, as it considers only one viewpoint.